If you love rock music, you know that sound, that absolute wall of sound.
Oh, yeah.
When the drums just hit you like an explosion, the guitar is ripping through the air, and the vocals, they just feel like they punch you right in the chest.
And a massive force.
It is. But how does a band go into a studio and capture all of that energy and, turn it into something so perfect and powerful on a record? That's what we're going to try and decode today.
It's a great mission because the first thing you have to get is that a recording studio is not just a rehearsal space. It's a highly specialized environment.
Built for precision.
Exactly. You're talking about soundproof rooms. They call them isolation booths. And they're built to eliminate any outside noise.
Like traffic or even an air conditioner humming.
Or even the sound of the bass guitar bleeding into the drum mics.
Yeah.
Total sonic control.
Right. And the technical setup is just as critical as the performance itself. I mean, a musician might spend an hour getting a perfect take.
Yeah. But the engineer might have spent 2 days just setting up the microphones to get that specific tone. It's all about meticulous preparation.
So it's not just about hitting record.
Not at all. And it's changed. Classic studios were these huge rooms that used natural echo. Think Abbey Road. Now you can get incredible quality in smaller spaces because of digital tech. The focus is more on surgical electronic precision now.
And the reason modern rock music sounds so layered and massive is all down to one single revolution: multi-track recording.
That absolutely changed everything. It was the turning point.
So before that, what did they do?
Before multi-tracking, the whole band had to gather around maybe 1 or 2 microphones and play the entire song perfectly, all at once.
Wow, that sounds agonizing.
Oh, it was. If the bass player messed up a note in the second verse, everyone had to stop and start the whole song over from the top.
The pressure.
Immense. But multi-tracking treats every instrument as its own separate thing, like an individual lane on a highway.
So the drums are on tracks 1 through 8, bass on 9, and so on.
You're building the song in layers.
And the flexibility that gives the engineer must be just mind-boggling. You can turn up the hi-hat
Without affecting the vocal.
and it let producers actually construct the music, not just capture it.
And that construction got complicated fast. The first systems had, 4 tracks? Maybe 8?
And now?
Modern systems can handle hundreds of individual tracks in one song. That ability to just stack sounds is how you get that thick, powerful rock texture. There might be 6 layers of rhythm guitar alone in a big chorus.
Plus, if the guitarist messes up one little chord in a solo, they can just re-record that tiny piece.
Yep, just punch in and fix it. The drummer doesn't even have to know. It saves so much time and, frankly, sanity.
So multi-tracking was the revolution. What's the modern engine that drives it?
That would be the Digital Audio Workstation, or DAW. It's a software that replaced all those giant old-school tape machines.
The DAW is where it all happens today, right?
It really is. And it doesn't just record the sound. It converts the audio into data, so you can see it.
You can actually see the music on a screen.
As a waveform on a timeline. You can zoom right in on one single drum hit.
So instead of physically cutting tape with a razor blade, which was a real job,
A very real and very stressful job.
they're just cutting and pasting with a mouse like we do every day.
And that made recording so much faster and cheaper. A DW can also host virtual instruments. Software that can perfectly mimic an old synthesizer or create flawless drum beats.
But before the sound even gets into the DAW, it has to be captured. And that brings us to microphones.
A whole science in itself. You can't just use one mic for everything.
Right, you wouldn't use the same mic for a whisper as you would for a jet engine.
An art built on science. In rock, you're mostly dealing with 2 main types.
Okay, let's break those down.
First, you have your dynamic microphones. These things are rugged, they're workhorses. They can handle super high volume without breaking.
So you'd put those on a loud guitar amp or a snare drum?
Exactly.
Yeah.
The snare, the kick drum, the guitar amp. The ones you see singers holding on stage are usually dynamics. They can take a beating.
And the other type?
Condenser microphones, they're way more sensitive, and they capture much finer detail.
So better for delicate sounds.
Perfect for vocals, acoustic guitars. Anything where you want to capture the nuance, the air around a performance.
And I've heard placement is just as important. The term polar pattern comes up.
The polar pattern is just the shape of the area where the mic hears from. A cardioid pattern, for instance, mostly picks up sound from the front.
So it rejects sound from the back.
Right, which is critical for stopping the cymbals from bleeding into the vocal mic.
And it's wild how moving a mic just 1 inch on a guitar speaker can totally change the sound.
That's the proximity effect. The closer a directional mic gets to something, the more bass you get. It can sound warm and full, or it can sound distorted and boomy if you're too close. The engineer's job is to find that sweet spot.
Okay, so all these microphone signals get captured and they all converge at one place, the mixing console.
The control center. It really does look like the cockpit of an airplane. Just rows and rows of faders and knobs.
And each one of those channels is one instrument, one microphone.
Yep. And the main goal there at first is just balance. The faders, the sliders control the volume of each track in the overall mix.
Making sure the drums don't drown out the singer.
That's the first job. But the console has another critical component inside it, the preamplifiers.
Why are preamps so important? Can't you just plug the mic into the computer?
The signal coming out of a microphone is tiny. It's a very, very low voltage. A preamp's job is to boost that tiny signal up to a usable level.
Without adding noise.
That's the key. A cheap preamp adds hiss. A high-quality preamp gives you a strong, clean, and clear signal. It's the first step to high-quality audio.
All right, so we have a clean signal, the volumes are balanced. Now we get to the artistry of it all, shaping the sound. Let's talk about EQ.
Equalization. EQ is your main tool for adjusting the tonal balance. It's about adjusting specific frequencies, from the deep bass to the shimmery highs.
So it's more than just the bass and treble knobs on a stereo.
Oh, much more. It's surgical. In rock, you use EQ to carve out space so every instrument can be heard clearly.
What's an example of that?
Well, the kick drum and the bass guitar both live in the same low-frequency area, so an engineer might cut a little bit of the bass guitar's energy at, say, 60 hertz to make room for the kick drum's punch.
So they're not fighting each other and turning into a muddy mess.
You got it. They each get their own little sonic neighborhood. And with rock guitars, you often boost the mid-range frequencies to get that aggressive, powerful sound that cuts through everything.
Okay, so the tone is set. The next big one is compression. To get this, we probably need to explain dynamic range first.
Right. Dynamic range is just the difference between the loudest sound and the quietest sound in a performance.
And if it's too wide, you're always reaching for the volume knob on your stereo.
Exactly. Compression is what manages that. It's a process that limits the range. Think of it like a robot hand that automatically turns the volume down on the loud parts and turns it up on the quiet parts.
So everything sounds more consistent.
And more present. It's vital for rock. You compress the vocals so you can hear every word over the loud guitars. You compress the drums to give them that explosive, punchy feel.
It's what glues it all together.
It really does. But you have to be careful. Too much compression is the enemy. It can make the music sound flat and lifeless. It just sucks all the natural energy out.
It's a fine line between punchy and pancake.
That's a good way to put it.
Let's talk about the more creative stuff, the effects that add atmosphere, like reverb.
Reverb is just the simulation of a space. It's the sound of a note echoing in a giant concert hall or a small bathroom. It adds dimension.
And they used to use actual echo chambers for this, right?
Yeah, they'd send the sound into a big reflective room and record the echo. Now, of course, it's all done with digital plugins.
And then there's delay.
Which is just a clean repeat of the sound, like
Yeah.
shouting into a canyon and hearing your voice come back. Hello, hello.
Hello! Great for adding excitement, but too much can make everything sound muddy.
Very muddy, very fast.
To get those really complex sounds, bands use a technique called overdubbing.
Overdubbing is key. It's just layering new sounds on top of what you've already recorded.
Like a singer recording their main vocal and then going back and singing harmonies with themselves.
Exactly. Suddenly, one singer sounds like a choir. Or a guitarist records their rhythm part and then listens back on headphones while they play a solo over it. It lets you create these huge arrangements that would be impossible to play live all at once.
Which brings us to the electric guitar. You can't talk about rock recording without talking about amplification.
Not at all. The electric guitar sound is entirely dependent on it. And the magic ingredient is distortion.
That fuzzy, aggressive, gritty sound.
That's the one. And it's basically intentional signal destruction.
You're pushing the amplifier so hard it can't handle it.
Right. The sound wave gets clipped. And that clipping creates all these new harmonics that add grit and, crucially, sustain. It makes the note ring out for much longer.
And to capture that intense sound, they put microphones right up against the speaker grill.
Right on the cabinet. And different amps, tube amps, solid-state amps, they all produce totally different tones. Finding that perfect guitar sound can take hours.
So with all these tracks, mics, and processes, who's the person in charge, the director of this whole symphony?
That is the music producer.
The person who's not technically in the band, but is just as important.
They're the project leader, the creative guide, sometimes the therapist. Their job is to help the band choose the best songs, decide on the overall sound, and just get the absolute best performance out of every single musician.
So they might say, hey, let's try a different drum beat here, or maybe we should cut this verse.
All the time. They're the objective outside ear that the band needs.
Hmm.
A great producer is often the difference between a good song and a massive hit.
Okay, so the producer signs off on the final mix. We're almost done. But there's one last super important step, mastering.
Mastering is the final polish, the last 5%. The mastering engineer takes the finished song and prepares it for the world.
So what's the difference between mixing and mastering?
Mixing is about balancing the instruments inside one song. Mastering is about making sure that song sounds great everywhere and that it fits with all the other songs on the album.
And with all the other songs on the radio or on a playlist.
Exactly. Consistency and optimization. This is where you hear about the loudness wars.
Making sure your track is just as loud as everything else.
Right. And the main tool for that is a limiter. It's like a hyper-aggressive form of compression that lets the engineer raise the overall perceived loudness of the track without it distorting. It's the final quality control.
Without mastering, your song might just sound quiet or muffled compared to everything else.
It's the step that makes it sound professionally competitive on headphones, in a car, anywhere. It is the final gatekeeper of quality.
It's incredible. Unpacking all this shows that rock music isn't just raw energy, it's this meticulously engineered process.
Every single decision is strategic. The angle of a mic, a tiny boost in an EQ, the amount of distortion. It all defines the final feeling of the song you hear. It's this perfect marriage of musical passion and technical physics.
It really makes you wonder, as technology makes it easier to get a technically perfect sound, does that push musicians to be better performers, or does it just give us more polished but maybe less raw sounding music? Something to think about. Good luck with your studies.